In retrospect, for you, this may seem like an odd way to start the next section that we want to talk about, but I want to point out that even competitive exclusion, or conditions where one species has a competitive advantage over another, can help create and maintain biodiversity because it favors adaptation, some sort of change in these species over time in order to limit extirpation or extinction. Okay, keep that in mind. What we want to do next is talk about a really helpful theory, a really good theory. When I say good, I mean a theory that has where there is a lot of useful information and one that is very helpful for understanding the world. And that's the theory of island biogeography. This is a theory that is easily understood in the context of actual islands that are surrounded by water, but it is not exclusive to that. So one of the things that we find is that as you increase the size of a particular habitat, let's say an island size, we tend to increase the number of species, different species that are on it. The number of species in a community will increase with the size of the habitat. There's just simply more variation and more potential for maintaining species. What we also find, however, though, is that those species diversity will also be increased by proximity to immigration sources. So regardless of what the habitat is, whether it's Alcatraz is shown here, or whether it is something else like a patch of grassland, species can be maintained by immigration into sites and as well as being maintained by the populations that are already there. So you have this interesting pattern that happens when you look across at islands. You can predict, so that this theory suggests that you can predict the biodiversity of those islands based on the island size and its distance to the mainland. And I say it's a good theory because it's really helpful for prediction. In general, in very general sense, those predictions are accurate. The larger the island and the closer it is to a source of immigration, the greater the biodiversity there. What we find is that those relationships change over time. So, with increasing distance, these are continuous variables, both the size of the island and the distance. And so we have continuous relationships here. So let's look at some examples. Here's, again, Alcatraz, which is a relatively small island. It's not very far away, but it is a small island, and it has somewhat low biodiversity. Of course, there's been a lot of development on it, and that also impacts the potential biodiversity there. But here's another example of an island, a herd island in the Southern Ocean. There's a series of islands that are far away from anywhere. They are small. They are in harsh environments. There are these volcanic peaks that are out in the Southern Ocean. They're small. They're very isolated. In both of these cases, they have low biodiversity, and particularly the herd islands, because they are small and they are far away. Now let's contrast that with islands that are relatively large and not as far away, and that includes on the left New Zealand, all of the islands included in it, as well as Madagascar. Now look at these two islands, both the plant and animal diversity, and you see just a lot of diversity. The islands are relatively large, and they are close enough to the mainland or to larger land masses such that there is immigration. Now, in both cases, there is a lot of unique biodiversity, both animal and plant in these islands, and that's because they are isolated and there is the emergence of biodiversity on there. There's adaptation and to the specific conditions there, and natural selection is ongoing with somewhat diminished relationships or influence of the mainland in these cases. Now, island biogeography is a theory which is which I mentioned is really helpful because it doesn't just apply to land. It also applies to islands in quotes. Imagine islands as habitat patches. So for example, this is the Rock Creek area in the Sierra Nevada. The mountaintops are potentially individual islands here, or the valley here is an island which is potentially separated from adjacent valleys by these rocky peaks. The matrix can be something like water, which surrounds actual islands, or it can be some sort of other habitat which may or may not be conducive to the species that exist, say, in the valley. So dispersal is an important thing, controls diversity when you have isolated patches of habitat, whether it's on islands or in this condition here. But sometimes that can be modified by the matrix quality. And what you need to keep in mind about biodiversity or island biogeography on land is that the matrix is not always as inhospitable as water. So here's a pretty neat example. This is the Madrean archipelago. This is a series of islands. They're called sky islands. They're mountains that rise out of the desert. They're in southeastern Arizona, northern Sonora, and a little bit of New Mexico. These are isolated mountain tops, and what we find here is that the size of the island, the size of the island, as well as its distance from other islands, determines the biodiversity that you find on these mountaintops. So Chiricahua Mountains are relatively big. They're quite diverse, both in terms of things like insects and plants, whereas some of these mountains that are smaller, Dragoon Mountains and so forth, that are smaller, more isolated, have lower biodiversity. The desert here is completely inhospitable to many, but not all of the species that you find on the mountains, and all of those things are interacting to control biodiversity. These are pretty cool place. When you look across all kinds of different habitats, you'll find these relationships where you have, with increasing area, you have an increasing number of species, and in particular, we find that there's greater adaptation, a greater endemism in areas with larger sizes. So, look at New Zealand, look at Madagascar, relatively large islands, and there's some really wild and unique biodiversity that has emerged there.